So the unit circle, all the hypotenuses are 1, the radius is 1, that's why it's called the 1 unit circle, or just the unit circle. So we know this already, that we measure angles from the positive x-axis. That's how we measure angles, whether we're in degrees or radians. So this first angle, like on the positive x-axis, we haven't gone anywhere, so that's 0 degrees. By the way, the big picture today is to fill in all the degrees, and then the second blank is radians to fill in all those, and then we'll flip it over and do a couple of problems, but we're not getting to the parentheses stuff yet. All right, so how about all the way around? What would this angle be? If we land at the same spot, well, we've made one full rotation, 360. We're going to kind of hop around to do the easy pieces first. So halfway around, what's that? 180. What about this straight up spot? Halfway between 0 and 180 would be 90. And how about the straight down spot? 270. How about halfway in between 0 and 90? Would be 45. So let's hit the 45s. Halfway between 90 and 180. That one's a little bit harder, but or 45 more than 90. 135. It's like we're counting by 45s. If your brain can sort of focus in on the 45 markers. So what's 45 more than 180? 225. 45 more lands us at 270. 45 more lands us at 315. And 45 more lands us at 360, which we already have. So we feel pretty good about those. Okay, there's still more blanks to go. This one looks like it's closer to 45 than to 0. And it's also one of the special right triangles that you did in geometry. Do you remember the angles of those? Like you did a 45, 45, 90. But you also did a 30, 60, 90. So that's why 30 and 60 are on the unit circle, or values that we care about. All the angles are on there, they're just not all labeled, right? Like 27's on here and 63's on here. They're just not labeled on there. So let's count by 30. So to count by 30, you do have to sort of ignore the, maybe this is overkill, but maybe it helps. Like if you ignore or literally cover up the 45s, it makes it easy to count by 30. And without the 5 on there, it's really easy to count by 30. So 30, 60, 90. What goes next? 120. And then 150. And then 180. It's already there, but that's a good check that we're doing this right. Why don't you see if you can fill in the rest of the 30 markers all the way around. So in radians, 0 all the way around 2 pi. Halfway around? Whoa, halfway between 0 and 2 pi is pi. Is pi. All right, back to so 0 to pi. How about halfway between 0 and pi? Pi over 2. And now I'm going to use that bar as the fraction bar. I mean, you don't have to. You can write pi over 2 on the blank, but why not just use the blank as the fraction bar? How about this bottom angle, halfway between pi and 2 pi? Right, that's that 1.5 thing, but we say 3 pi over 2. Okay, now we got to really be careful with our fractions here. Halfway between, so now I'm sort of ignoring my I want to ignore my 30, 60. I only want to look at the 90 or the 45s here. So halfway between 0 and 90 is 45. Halfway between 0 and pi over 2 is pi over 4. Right? We good with that? Half of a half? Halfway through the first half is the end of the first quarter, pi over 4. So that 45 degree opening is pi over 4. So we can kind of count by pi over 4s. So this first one is pi over 4. 45 more is 2 pi over 4. But that matches, if you can reduce in your head, 2 pi over 4. 45 more is pi over 4, 2 pi over 4, 3 pi over 4. 1/4, 2/4, 3/4. This is part of what I mean by not having to memorize everything. You can count and do a lot of just kind of figuring out. Okay, so 1/4, 2/4, 3/4, 4/4. Okay, that matches. 4/4 is 1. 5/4. Keep rotating. That's 5/4. 6/4. But that matches. 7/4. And 8/4, which is 2. So there's some built-in checks. Once you make it all the way around, you better land it at 2 pi or 360 if you're in degrees. Uh-oh, we probably don't know what 30 degrees is in radians. 30 degrees in radians? I could give you a hint by saying convert it. It's pi over 6. But I don't need to do that conversion ever again because now I know that I can count by, if I look at my 30 degree markers and ignore my 45 degree markers, I can count by pi over 6. Like each 30 degree increment is worth pi over 6. So this is 1 over 6. This is 2 over 6. But don't write 2 over 6 because 2 over 6 is 1/3. So pi over 3. So you're counting by 6, but you have to reduce like 2/3 of them, 3/4 of them, a bunch of them. So 1 over 6, 2 over 6, 3 over 6. Yep, that's right. 4 over 6. Wait, but 4 over 6 reduces. 2 pi over 3. And then if you're like me, after you reduce, you forgot where you were, so you go back and start counting again. 1/6, 2/6, 3/6, 4/6, 5/6. 6/6. Okay, but that's 1, so we're good there. Why don't you keep going and see if you can finish the rest of the way. 6/6, 7/6, and so on. But reduce when you can. And then, so 4 pi over 3, 6/6, 7/6, 8/6, 9/6. Evan, what goes in this blank?
I don't even know.
Let's count by 6. So 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, but 10 over 6 reduces to 5 over 3. 5 pi over 3. And then Austin, 11 over 6. And then just to check, one more would put us at 12 over 6, which is 2 pi. So now we've got the angles labeled all the way around in radians and degrees. And what's kind of fun about the angles in radians in particular, even though you don't like radians, is that if you look at every denominator that has a 6 in it, every denominator that has a 6 in it has a reference angle of, what would you say the reference angle for each of those is? 30 degrees. And even better, what is it in radians? Pi over 6. So anything over 6 has a reference angle of pi over 6. That's kind of convenient. I would strongly suggest you get a highlighter out and mark all the over 6s in the same color. This is going to be super helpful later. It's not so big a deal now. You're going to need 3 colors, so you may have to borrow and trade with friends. I've got some colors I can share as well. Does anybody want a green? You ready for a catch? Or I have another green. Step out. Nice grab. Well, sort of a grab. Did it hit the ground or did he? Nope, incomplete pass. All right. So mark all the over 6s with one color. It doesn't matter which color. You don't have to pick green. And then look at all the over 4s and pick a different color. Again, very few people are carrying around 3 highlighters, so help each other out. Oh, my orange is dying on me here. So I put all my over 4s in orange, but again, the specific color you pick doesn't really matter. All the over 4s, what's the reference angle for all the over 4s? 45, and in radians it's pi over 4. So all of your over 4 angles have a reference angle of pi over 4. Basically, reference angles on the unit circle are super easy because it's whatever the denominator is. All right, pick one more color and do the same thing with the over 3s. Does anybody need another color? I got yellow and blue. Anybody need a green? Good grab. Same question. Look at all the over 3 markers that you just shaded, colored, highlighted. What's the reference angle for all the over 3s? What is it in degrees, first of all? 60. And what is it in radians? Pi over 3. So it's very convenient, very nice that all the reference angles, if the denominator is 3, the reference angle is pi over 3. If the denominator is 4, the reference angle is pi over 4. Denominator 6, the reference angle is pi over 6. You have to be careful that doesn't work for if you get something crazy like over 7 or over 11 or 13, but on the unit circle, all the denominators are 3, 4, and 6. Well, and 2, I guess. But those are the ones that are straight up. It still works with 2 because the reference angle for pi over 2 is pi over 2. And I don't know which x-axis you would go to, but either one is pi over 2. All right, that's going to help when it comes to these sine and cosine values. We're not there yet, but that's sort of where we're headed. Let's flip this over. You know what? Let's don't do it on the back because this is gonna travel with you for a good while into next semester. So I don't want to put extra work on the back. We got a few more things to do. Thank you. It's not long, but I don't want to put it on the back because I want to keep this nice and clean and pristine, because that's going to be super important later. And because you probably want to refer to it as we answer these questions. So we're just going to do 4 quick questions together, and then we'll do one off of worksheet 1. We did a little bit of this yesterday. Find the quadrant of 23 pi over 6. Find the quadrant of 23 pi over 6. Well, in some ways, I feel like, well, that's not on the unit circle, 23 pi over 6. And I'm going to argue it is on the unit circle.
It's the 11 pi 6, right?
Where'd you get 11 pi over 6 from? You're right. Where'd that come from?
Like 330.
But how did you know to land at 330?
Well, because it's like almost 2 of the full circles.
Okay, that's really good. The big thing today is the coterminal. The idea of coterminal. What was the rule on how to find coterminal angles? Right, add or subtract 2 pi or 360, depending on which one you're doing. Yesterday we started with one that was like between 0 and 360, and we sort of expanded it out. Today we're going to do it the opposite way. We're going to look at one that's sort of outside our normal viewing window and get it back to something normal. So let's subtract 2 pi. Of course, we have to have a common denominator. So if we subtract 12 over 6, we get 11 over 6, and that is, well, 23 over 6 is on the unit circle too. 11 over 6 is easy to find on the unit circle. It's almost 2 pi, so that's quadrant 4. Now, if you can do basically what Luke did, you look at that and you're like, well, that's almost 4 pi, so that's almost 2 times around. So that's like all the way around and still in the 4th quadrant. Like all the way around once and then into the 4th quadrant. Let me pick one that it's harder to do that with. Negative 17 pi over 3. I don't know where that is. It's going backwards a bunch of times. What should I do to get that in, to find a coterminal angle that's between 0 and 2 pi? Let's add, because if I subtract, I'm going to start going more negative, and that won't help. So this time, let's add 2 pi. Don't forget, you got to have a common denominator. So negative 17 pi over 3 plus 6 pi over 3 is negative 11 pi over 3. That's still not very nice. So what do you want to do? What do you want to do now?
Keep adding.
Yeah, just keep adding 2 pi until you get something you like. So plus 6 pi over 3 is negative 5 pi over 3. Some of you are going to stop there and you're going to think, okay, I can go backwards almost 2 pi, and you'll know what quadrant you're in. Do you know where that would land you at? Yeah. Oh, nope. But you got to go backwards almost all the way around. But backwards almost all the way around will put you into the 1st. So, yeah, most of you, I guess, aren't quite there yet. But if you're not sure where negative 5 pi over 3 is, what could you do to get another coterminal angle? Just add again. And so rather than try to trick your brain into counting backwards, like, you know what, let's just add 2 pi over 3 again. Or excuse me, 2 pi. We get pi over 3. And that's definitely in quadrant 1. So as soon as you figure out where it is, you can stop playing around with coterminal angles, but you can also always get it to something between 0 and 2 pi. All right, I think that one's easy. How about 247? What quadrant's that in? Especially if you're looking at the unit circle. Where does 247 fall? The third quadrant, right? It's a little bit past 240. It's not to 270. So that's quadrant 3. I didn't have to do anything with that. What about negative 913? I don't know. You're backwards and you're spinning, so let's add 360 to that. And that's kind of yuck, so I'm looking for a calculator so I don't mess up my... You could just add 720, because you know that adding 360 is not going to be enough. So add 360 again. Negative 193. So some of you are able to think backwards and figure out where negative 193 is. Anybody want to guess what quadrant negative 193 is in?
4. Oh, 3.
Got all sorts of numbers. So negative means I got to go backwards. You'd have to pass 90. You'd have to pass 180. I think you'd end up in quadrant 2. Again, if you don't like going backwards, which some of you shouldn't like going backwards yet, add 360 again and get 167. And you're like, okay, 167 is definitely in quadrant 2, so I'm not worried about that. I'm good now. All right, grab your grab your worksheet packet, and let's do number 1, just because I'm not sure the directions are clear on what they want you to do. Worksheet 4, indicate each angle on the unit circle. So 60 degrees. So it wants you to find 60 degrees. Let's see, that'd be between 0 and 90, a little bit closer to 90, so probably about right there. And you could label it 60, or you could just label it A for 60 degrees. Let's see, angle B is 280. What quadrant would 280 be in? 4. And is it closer to the down one or closer to the right one?
Down.
Yeah, because it's 10 past 280, so it's pretty close. All right, a negative 1. Add 360 if you like. Or, do you know what quadrant negative 225 would land you in?
2.
The second quadrant. Good, so we're getting a little better. If you need to add 360, you get 135. This is right in the middle of the second quadrant. And then 10 degrees is an easy one, just barely anywhere. So that's what 1, 2, 3, and 4 are asking you to do. Label the angle on the picture. And obviously I'm not going to be getting a protractor out and checking your work. It definitely has to be in the right quadrant, and it really needs to be correct in terms of, is it closer to the x-axis or y-axis, or straight in the middle. So I think worksheet 4 is maybe the easiest one we've done, but it's headed toward the unit circle, so we got to make sure we know where all the angles are.